Alright guys, so again, systems of linear inequalities. We're dealing with multiple inequalities. Okay, so the first part asks me to identify whether the given point is a solution. Okay, so whether the given point is a solution. So this is going back to what we have previously done in our course. We already know how to do this. All I have to do is take this and plug it in. If it makes the inequality true, both of those, then it is a solution. If it does not make either one of those true, if one of those is false, then it is not a solution. So all I'm doing is I'm taking the x value, which is 1, plugging it in. I'm taking the y value, which is a -3, and plugging it in into both inequalities. Again, it has to be true for both of them, right? In order for it to be a solution to my system, it's got to be a solution to both inequalities. So here we go. Y, but again, I'm replacing the y with what y is equal to. Y is equal to -3. So this is -3 is less than or equal to x, which in this case is 1, minus 2. So I've got one more step. -3 is less than or equal to 1 plus a -2 is -1. So is -3 less than or equal to -1, Hayes? Yes or no? Is -3 less than or equal to -1? Yes. It is less than. Okay, so that is a true statement. So now, let's go to the next one. Right? Because it has to be true over here also for it to be a solution. So let's go -3 is less than 6 times 1, plugging in the x, plus 3. So is -3 less than 9? Obviously that is also true. So yes, this is a solution. Alright, going on to B. Is the point -2, -3 a solution? So once again, I'm going to do the same exact thing. I'm plugging the x in there, I'm plugging the y in there, I'm plugging the y in here, and I'm plugging the x in here. I've got to do it to both of them. So in this case, y, -3 is less than -3 halves x, which is a -2, plus 1. Okay, so I'm dealing with fractions, no big deal. Ain't no thing but a chicken wing. Okay, so I cancel because that's a -2 over 1. So I've got a -3 times a -2, and I get positive 3 plus 1. So is -3 greater than 4? That's not a true statement. So no, this is not a solution. Well, that's not even close to a useful solution. Alright, doing all mass, same thing. I'm going to plug in 0 for x. I'm going to plug in -2 for y. So this is -2 is greater than 1/2 times 0 minus 2. So is -2 greater than -2? No, sir, it is not. It is equal to. So once again, that is a false statement. I know right now that this is not a solution. You don't even have to go to the next one. It's got to be true in both inequalities for it to be a solution. It's got to be true in both inequalities for it to be a solution. Ryan, you getting this? Alright, now, we've also talked about how to graph linear inequalities. Okay, so I'm looking at A on the bottom. Right, graphing linear inequalities. So we remember that there are two rules when graphing a linear inequality. Okay, everything else is the exact same when I graph a linear equation, with the exception of two rules. Graham, can you tell me what one of those two things is?
For graphing them?
When I'm graphing a linear inequality, I need to figure out the type of line. The type of line can either be what or what?
Solid or
yeah, solid or dashed. Okay, solid or dashed. And Graham, do you remember how I tell whether it's solid or dashed?
No.
By my inequality. So if there is a line underneath my inequality, Graham, I make a solid line. If there is no line underneath my inequality, it is not equal to, therefore it has to be a dashed line. So the first thing, the first difference, everything else is the exact same. Graphing a linear inequality from a linear equation. The first difference is whether it's a solid or a dashed line, and then the second thing I need to do is I need to figure out whether to shade above or below. And again, that is from the inequality symbol. So that inequality symbol, less than, will tell me to shade below. Less than will tell me to shade below. Alright, so let's look at part A. Let's look at question A. We're going to graph this system of linear inequalities. So I'm graphing my first inequality. It's in y equals mx plus b form. So we're Gucci. So the first thing I need to do is I need to graph my y-intercept, which in this case is a positive 2. Go over 0, go up 2, there's your first point. Easy breezy. From there, look at your slope, m, rise over run, which in this case is rise 1, run 3. So I'm going to go up 1 and to the right 3. Bada bing, bada boom. Go up 1 to the right 3. Bam. Go up 1 to the right 3. All right, now, here's where my changes take place. Do I put a solid or a dashed line? Well, I go back and look at this inequality symbol. There is a line underneath, therefore, I make a line. Alright, so there's my graph. Now, the second change takes place, shading above or below. Go back and look at your inequality symbol. It's a less than symbol. I shade below. So I'm shading all of this. Alright, now, there's one of them graphed. Again, this is a system. This is a system, meaning that I need to graph both of them. So let's go to my next inequality. Y is less than 2x minus 3. Y is less than 2x minus 3. All right, so Elijah, help me out. What is my first point? What is the first point that I'm plotting, Elijah? Okay, not just 3. No. What does it say up there? That doesn't say 3. It says what? Okay, so I'm going to go over. This is my y-intercept. So I'm going to go over 0. I'm going to go down 3. Plot that point. Now, Elisha, I look at my slope, which in this case is not just the 2. I don't care about the x. It's the number in front of the x. And again, that's 2 over 1. So from my first point, I'm going to rise how many, Elisha?
2 over 1?
Yep, rise 1, 2 over 1. Bada bing. Rise 1, 2, run 1. Bada boom. Rise 1, 2, run 1. Bam. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1, etc., etc., etc. Now again, here's where your change takes place, right? Figure out whether it's a solid or a dashed line. Ryan, is this a solid or a dashed line? Dashed line, because once again, there is no equals to underneath. So if there is no line underneath your inequality symbol, you do not make a line. Alright, so there's my second line, my second inequality. Now I need to figure out whether I'm shading above or below. Alright, Andrew, help me out. Am I shading above or below based on that inequality symbol? Based on that inequality symbol. Tell me in words what that inequality symbol is. Tell me in words, what is that inequality symbol? Is it less than, greater than, less than or equal to, greater than or equal to? Less than. Okay, so if you think, if it's less than, do you think you're shading above or below? Below. Okay, so I'm shading below this line. Okay, I'm following this line. So all of this is shaded in. Now, what is your solution set? Your solution set is what is shaded twice. Your solution set is what is shaded twice. So what is shaded based on this line is all of this. Right? And then what is shaded based on this line is all of this. This is not part of my solution set because that's not shaded twice. This is not part of my solution set because that's not shaded twice. What is all of this right here. Every point in that area is part of your solution set. Every point in that area is a solution. Right? So if I go down, it says name 3 solutions to this system. We'll just pick 3 points. There's a point right there at 4, 0. That's a solution. You've got a point right here at 6, 1. Whatever. Doesn't matter. As long as it's within your shaded area right there, it's part of your solution set. You got a point over here at 5, negative 4. Any point down here works. Well, what is not a solution to this system? Well, 0, 0 is not because it's not shaded in twice. Okay, any point up here is not shaded in even once, so those are not solutions. Any point right here has only been shaded in once. Those are not solutions. Any point up here has only been shaded in once. Those are not solutions. So you can have a lot of answers. So again, the difference, guys, that we're talking about today is we're not going to get a single point for your solution. If it's a linear equation, if they are equal signs, you will. Maybe. You may get infinite many. You may get no solution. Okay, or you'll get a point of intersection. So if this was a system of linear equations, guys, that would be your solution because that's where they intersect at. It's not. It's inequalities. So I have a solution set, which is all of this shaded area right here. That's part of my solution set. Every point in that shaded area is a solution. Let's go to the next one. Let's go to B. All right, now, B, they are not in y equals mx plus b form, especially the second one. So guess what? We got to put it in y equals mx plus b form. All right, but I can graph the first one. Okay, Ryan, can you help me graph the first one? X is less than 3. Okay, so let's do this, Ryan. X equals 3. In our mind right now, let's graph that equation. Let's graph that equation. Okay, so now this is a special case, right, Ryan? This doesn't look like this. Y equals. This says x equals. This is a special case. Okay, can you tell me? My 2 special cases for linear equations are vertical lines and horizontal lines. Which one is this going to be?
It's going to be, like, vertical's like from left to right.
Vertical is up and down, right? So if you're jumping, right, that's your vertical leap. And then horizontal is left and right. Okay, so can you tell me which one this is going to be?
It's going to be vertical.
Okay, so think about this, Ryan. X equals 3. Okay, so let's make a point. I'm going to say that x is 3. What do you want y to equal? I don't care. 3? Okay, so we got a point at 3, 3. So go over 3, go up 3. There it is. All right, Ryan, let's make another point. I'm going to say that x equals 3 because it has to. What do you want y to equal? I don't care. 6? Okay, 3, 6. Over 3, up 6. Uh-oh. Okay, Ryan, let's make one more point. 3. What do you want?
8.
8. Over 3, up 8. Okay, Ryan, let's try this again. Is it going to be a horizontal line or is it going to be a vertical line? Yeah, up and down, which is a...
Oh, I said vertical.
No, you said horizontal.
I said horizontal?
Yeah, it's a vertical line, right? It's up and down.
Okay.
Okay, so now we figured out that it's a vertical line at x equals 3. Okay, so now let's go back and look at my inequality symbol because, again, we're back over here. We've got 2 differences for a linear inequality. First difference, figure out whether it's shaded, solid or dashed, excuse me. Okay, figure out whether it's solid or dashed. All right, so Hayes, I'm back to you. Is this, based on my inequality symbol, a solid or a dashed line? Is there a line underneath that inequality symbol? Dashed line. If it's not a line underneath, it's not equal to. And if it is not equal to, it has to be a dashed line. All right, there we go. So first difference, solid or dashed. Second difference is to figure out whether I'm shaded above or below. Okay, so now this is a special case because I can't shade above a vertical line. I can't shade below a vertical line. So what I need to do is I need to figure out what numbers make this true. X is less than 3. So I need numbers that are less than 3. Right? So 2 is less than 3, 1 is less than 3, 0 is less than 3, etc., etc., etc. So I need to be shading on the left side over here because these numbers are less than 3. So all of these numbers are solutions to that inequality. So we've done been graph one of them. All right, now let's graph the other one. So now I'm looking at this inequality. Now, once again, it's not in y equals mx plus b form, so I need to solve for y. I need to solve for y. All right, Riley, help me out. Let's solve this inequality for y. What do I need to move?
2x.
So I'm going to subtract 2x on both sides. I got negative 3y is greater than or equal to negative 2x plus 3. And once again, guys, I wrote the x first because that's how it is in y equals mx plus b form. Divide by what? Divide by what? No, you're right. Keep saying it. Divide by what 3? Negative 3. Okay, why do I keep saying that, guys? Because I'm dealing with inequalities. And anytime I multiply or divide by a negative number, Elisha, what do I need to do with that inequality symbol? Inequality symbol. Anytime I multiply or divide by a negative, I flip the inequality symbol. Okay, so anytime I multiply or divide by a negative number with an inequality, this is not new, guys. You should remember this. Anytime I multiply or divide by a negative, I have to flip the inequality. So we're dividing by a negative 3, Riley said, which is absolutely correct. So that goes away. I got y is less than or equal to, because again, I'm flipping the inequality symbol. Keep the line underneath. Keep it equal to. All I'm doing is changing it from greater than to less than. This is a negative divided by a negative. It becomes a positive 2/3 x minus 1. Now we can graph. Now it's in y equals mx plus b form. All right, so Ryan, what is the y-intercept? What's my first point? Yes, I'm going to go down 1, graph that point. Bada bing, bada boom. From there, look at my slope. My slope is up 2, rise, over run, 3. Up 2 over 1, 2, 3, bam. Up 2 over 1, 2, 3, bop. Up 2 over 1, 2, 3, bing. All right, now, again, I need to figure out how to connect these lines. There's a line underneath. So, Graham, what am I doing?
It's a solid line.
Solid line, fantastic. So there is my graph. Now the second change takes place. I got to figure out whether I'm shading above or I'm shading below. Andrew, can you tell me, am I shading above or am I shading below? Tell me in words, Andrew, what is that inequality symbol? It is a less than or equal to, Andrew. Okay, so tell me, am I shading above or below? Fantastic. Andrew, you did this one right here, right? And this is a less than symbol. And you told me a less than symbol, I shade what? Yeah, okay, so this is a less than or equal to. So I'm still shading below the graph. All right, so now I'm shading all of this. So again, your solution set, guys, is what's shaded in twice, which is why I'm shading this so darkly right now. because that is shaded in twice. Now I keep going over here because those are solutions to that equation, or sorry, inequality. So again, what is your solution set? Your solution set is what is shaded in twice. I shaded all of this area in twice because it is a solution to both inequalities. So now it asks for 3 solutions to this system. All right, well, let's pick some 3 easy points. -4, 0. -2, -6. Don't matter. 2, -2. Don't matter. What's not a solution? Well, 2, 0 is not a solution because it's not shaded twice. I can pick any point up here. Those aren't even shaded in once. Okay, so 6, 4 is not a solution because that's not even shaded in once. Any of those work. So again, you're treating it just like a linear equation, guys. Treat it just like a linear equation. This is nothing new. The only thing that is new is whether we're shading twice. That's the only thing that's new. We know how to graph inequalities. We've done it. We know how to shade above or below. We've done it. We know our solution set. We've done it. The only difference now is we have 2 of them. So now you got to figure out where am I shading it twice, and that is your solution set. Again, the difference between systems of equations and systems of inequalities is to figure out that it is not a single point of intersection, it is a solution set. It is a solution set. All right, so flip your paper over or scroll down, whatever you're doing. It says, look at the type of line and location of shading to determine the inequality symbol. So it says, use a less than symbol for a dashed line, because again, there is no line underneath that inequality symbol, with shading below. This again would be a dashed line, because again, there's no line underneath, but I would be shading above that because that is a greater than symbol. This is a solid line, because there is a line underneath, it is equal to. This is a less than symbol, so I would be shading below the graph. This is a greater than symbol, so I'd be shading above the graph. So I'm looking at what type of inequality it is based on my graph, right? So now I've given the graph, and I'm asked to write my system from the graph. Okay, well, again, this is nothing new, right? We know how to write inequalities from a graph. We've done it. We know how to write equations from a graph. We've done it. So the first step, decide what your 2 inequality symbols are based on your line. So if I'm looking at part A, this is a solid line, so you know it has to be A equal to. I'm also shading above that line because here's your solution set. So I know it has to be a greater than or equal to symbol. So line 1, which is this one right there, would be a greater than or equal to symbol. Now obviously it has to be Y is greater than or equal to. Line 2, which is this one going down, is a dashed line. So I know it cannot be equal to, and I am shading below that dashed line. So it has to be a less than symbol. So now step 2 says to calculate the slope by counting rise over run between 2 points. All right, well, I would actually start with the y-intercept, right? So the y-intercept here is at +1. So I know on line A, this is a +1. On line B, it goes through -3, so I know that this is a -3. From there, let's find another point on the graph, right? So again, I'm looking at where it crosses the box in the corner, which would be right there, or I could say right there. So now, how do I get from here to here? I went up 2 over 1, 2, 3. So this is a 2/3, and it's a positive slope because I'm going up and over 2/3 x. So I just wrote my inequality. There it is. Go to number 2. Now, this is a negative slope because that's going down. I'm yelling timber. No? Nobody? Okay, never mind. All right, so now how do I get from this point to this point? I'm going to go up 1, 2, and over to the left 1, 2, 3. Okay, so again, this is a negative slope because I'm going downward. So I'm going down 2 over 3. Negative 2/3 x minus 3. So this would be to substitute that value in for m, substitute that value in for b. All right, I'm going to do number B, or letter B for us, and then y'all are going to help me do C and D. So again, let's make one of these line 1. It doesn't matter. It'll say that this is line 1. I know that line 1 has a negative slope. I know that the inequality symbol is not equal to because it's a dashed line. Okay, so I know I'm also shading below that line, and I know it has to be a less than symbol because I'm shading below that line. Here's my solution set. Okay, so 3 things I got from that line right there. I got that it's a not equal to because it's a dashed line. So I'm either choosing less than or greater than for my inequality symbol. I know I'm choosing less than because I'm shading below. Okay, so y is less than. I know that my slope is negative because that graph is going down. I know it has a y-intercept of +1. So the b will be +1. Now to find my slope, I find another point on the graph, which is that point right there. And I figure out, how did I get from point 1 to point 2? Well, I went down 1, 2. I went over 1, 2, 3. So once again, we have a negative 2/3 for our slope. All right, line 2 is going up. So line 2 has a positive slope. Y is, once again, it's a dashed line. So you're choosing less than or greater than. I know that it's still shaded below the graph. So it has to be a less than symbol also. The y-intercept is right here at -2, so this b is going to be -2. And now how did I get from this puppy to that kitty cat? I went up 1 over 3, so 1/3 x. Bada bing, bada boom. All right. Let's go to letter C. So let's say that this on letter C is line number 1. That is a horizontal line. Okay, so Ryan, that is a horizontal line. Can you help me write my first inequality? Right here, line 1.
1, -1.
Okay, so y, -1. So I agree. Okay, so if this was just an equation, it would be y equals 1. If that was an equation, but it's not because that is a dashed line and it's shaded. So that's what tells me that it's not y equals. That's what tells me it has to be an inequality symbol here. So now let's choose what inequality symbol it is. It is a less than symbol because I shaded below that line and it is a dashed line. So y is less than 1. Fantastic job, Ryan. All right, so let's go to line number deuce, which is this one right here. Now, that's a solid line. So we haven't done one of those yet. Okay, solid line. So Graham, help me out. Okay, I've got y. From that line, can you tell me what is my inequality symbol? Let's narrow it down. Let's narrow it down. Okay, so we've got 4 inequality symbols. We got greater than, less than, greater than or equal to, less than or equal to. Let's narrow it down to 2 of those, Graham. Which 2 can I eliminate?
Less than.
Less than or?
Less than or equal to.
No.
Oh, I mean,
Greater than.
greater than.
Because again, this is a solid line, meaning it has to be equal to. Okay, so I can eliminate all the ones that are not equal to. Well, less than and greater than are not equal to. So now I'm choosing between 2 inequality symbols, less than or equal to, greater than or equal to. Now you look at where it's shaded at to choose. Okay, so Graham, is that shaded above that line or below that line?
Above.
Above. So what's your answer?
Greater than or equal to.
Fantastic. Greater than or equal to. There's my inequality symbol. Okay, now I'm looking at my y-intercept, which is right here at -3. Bada bing. Now I look at my slope, which is right here in the next point. So I'll go up 1, 2, over 1, 2, 3. So once again, we've got a slope of 2/3. I don't know why I liked 2/3 apparently when I made this, but it is what it is. All right, Hayes, you got D. So help me out. Here's line number 1. What is the y-intercept for line number 1? Okay, so I know it's going to be y something something plus 1. Okay, is this a positive slope or a negative slope? Okay, so I know it's going to be a negative slope. All right, so now let's find another point on the graph, which I'm going to say is this point right here. How did I get from point 1 to point 2? So negative down 4 over 1. Okay, so I don't have to write over 1 because it's understood. So negative 4x. All right, now last thing I need to do, or whatever I need to do now, is I need to figure out my inequality symbol. Okay, so this is a solid line, Hayes, and it's shaded below the graph. So what are you picking? -4x plus 1. Fantastic. Okay, so line number 1's done. Line number 2. Andrew, help me out. Okay, I've got a y-intercept of what? Okay, so this is going to be -2. Okay, now I know it's it's a negative slope. Okay, so how do I get from here to here? Because that's another point on the graph. Okay, how am I going? Am I going up, down, left, right? What? Just talk to me. Just talk to me, Andrew. I'm going down 1, right? I'm going to go down 1, and I'm going to go over to the right 1. Yeah, so -1x. So I don't have to write the 1. I just write -x. Okay, so y something. Now I need to pick the something. What's my inequality symbol? So once again, Andrew, this is a solid line. So I know that there needs to be a line underneath. Now this is shaded above or below that line, Andrew? Above. Greater than. So there's your system of inequalities. Great job. Questions there? Yes, no, maybe. Okay.